Welcome to Challenging GCSE Maths Questions with Mr. Wesley. Every day, we take on one mind-boggling GCSE maths question designed to stretch your brain and push your skills to the next level. Mr. Wesley will break it down step by step so you can confidently ace those tricky final questions on your exam. Grab your notebook, your pen, and your calculator. Let's get solving. Oh, and before we dive in, make sure you hit that like button and subscribe. If you have any challenging questions you would like Mr. Wesley to solve in the upcoming videos, please email him the question. His email address is in the description. All right, let's do this. Here's Mr. Wesley.
Okay, take a look at this question. This is one of the hardest questions I've come across in GCSE Maths. A semicircle with radius r, which is in purple and shaded, is inscribed inside a quarter circle that's in green with radius 12 centimeters as shown. Part A, find the exact value of r. Part B, show that the semicircle occupies 2/3 of the quarter circle. Okay, pause this video please and try to do this by yourself. If you still can't, you can always come back to the video. So the first thing I'm going to do is join the center of the quarter circle to these 2 points. This one and this one. So because the radius of the quarter circle is 12, this is 12, this is 12, and this is 12. Okay, that's a good start. Then I'm going to take the center of the semicircle and join that with the touching point at the tangent. In fact, where the 2 tangents touch the semicircle. So our circle theorem tells us that this is 90 degrees and this is 90 degrees. So if you take a look at this quadrilateral, you'll soon realize this is 90 degrees, this is 90 degrees, this is 90 degrees, therefore this also must be 90 degrees to make it 360 degrees total. So this is at least a rectangle, but this is r, that's the radius of the semicircle. This is also radius of the semicircle. This is also radius of the semicircle, and so is this one. So the orange rectangle is now a square because the sides are equal. We've shown this is r and this is r. So if I were to join these 2 points, this will be square root of 2 times r. Why? Because we have r, therefore if I call this a squared is r squared plus r squared, Pythagoras, 2r squared, take square root from both sides, that diagonal is square root of 2r. Now I would like you to look at this triangle that I'm highlighting in light blue. Okay, this is square root of 2 times r. This is r, and this is 12. So we have a right angle triangle, and we can use Pythagoras theorem again. And let's see if we can find the exact value of r that way. So I'm going to copy this light blue triangle here, and let me scroll down. So we have shown that this is root 2r, this is r, this is 12, and this is right angle. Would you like to check and make sure? Yes, root 2r, r, and 12. So if we use Pythagoras theorem, root 2r whole thing squared plus r squared is 12 squared. 2r squared plus r squared is 12 squared. I'm going to keep it as 12 squared because we're going to take square root in a minute. 2r squared plus r squared is 3r squared is 12 squared. Now for root 3r is 12. Dividing by root 3 on both sides, r is 12 divided by root 3. Now if we were to rationalize this, I can multiply by root 3 times root 3. So 12 root 3 divided by 3, that will be 4 root 3. So we have found the exact value of r. Now let's go to part 2. Show that the semicircle occupies 2/3 of the quarter circle. So I'm going to erase everything except r, and I'm going to write that r is equal to 4 root 3. Now, what's the area of the semicircle? Okay, so if it were a full circle, it would have been pi r squared. So pi times 4 root 3 whole thing squared. But we only have semicircles, so half of that. So this is equal to pi times 4 squared is 16, root 3 squared is 3, divided by 2. 16 times 3 is 48, divided by 2, 24 pi. So this is the area of the semicircle. Now, the area of the quarter circle, we know that the radius is 12. So what's the area of the quarter circle? So if it were a full circle, it would have been pi times 12 squared, but we divide that by 4 because it's a quarter circle. 144 pi divided by 4, that is 36 pi. that is the area of the quarter circle. So, what fraction of the quarter circle does the semicircle occupy? 24 pi divided by 36 pi. So 24 pi divided by 36 pi. Pi cancels out. 24 divided by 36, there's a common factor of 12 in both. So when you simplify, you'll get 2 over 3 as required. So let's scroll up and see. Find the exact value of r. That was 4 root 3. Show that the semicircle occupied 2/3 of the quarter circle, which we have shown also. Thank you for watching.
Great job today, everyone. Remember, the key is to take your time and practice the questions regularly. If you found this video helpful, please like, comment, and subscribe. It really motivates Mr. Wesley to create more videos. If you have any questions, feel free to email Mr. Wesley at wesleymathstutor@gmail.com. See you in the next one.